Hello everyone, we've got this paper and it's a calculator one, so that's good. It's paper 3 from June 2024 and it's the foundation level. One other thing before we start, there's some mid-roll adverts appearing in some of my videos, which I'm not doing. That's YouTube doing it. If I could remove them, I would, but for that I think I need to be monetized. But if anybody knows of another way, then let me know and I'll do it. Thank you very much. Let's get on with it. Question 1. The village has 4 bus stops. The bar chart shows information about the people at the bus stops at 3 p.m. one day. Number of people waiting at each bus stop at 3 p.m. There's our number of people down there. Here's our various bus stops. 2 people were at the football ground bus stop. Show this information on the bar chart. Okay, well there's the number of people. There's 2. 2 of them we've got to put in. So it's just like this. That's that bit. And one other thing, the reason I read through every question is because if I make a mistake, that's usually where the problem is. I haven't read the question. How many more people were at the school bus stop than at the post office bus stop? Well, post office is here. That's 4. What's the one? School bus stop is here. That's between 12 and 14. This has got to be 13, isn't it? Okay. 13 minus 4. I'm going to put that there. 13 minus 4. And I'll put the answer down wherever it's got to go. That's 9. There are 4 temperatures in degrees C, -5, 3, -7, -1. Write the temperatures in order, starting with the coldest. Oh, the coldest. Well, that's the most negative, which is going to be -7. And I look to cross these out when I've done them. -5 is the next one. -1. Let's do it properly. And then 3. Question 3. Here are the first 3 terms of a linear sequence, 5, 11, 17. Write down the next term. So linear is the same as arithmetic sequence. What's the difference between them? It's 6 plus 6 plus 6. Okay, so we have to add 6 onto this. 17 plus 6 it's 1 mark. So that's going to be 23. Describe the term-to-term rule. I think that just means add 6 or plus 6, add 6. I don't think it means they don't want the formula for working out the nth term. They just want the rule. Lucas spends 71 pence. He pays the exact amount with 4 coins. List the coins he uses. Okay, so we've got 50 pence, haven't we? We've got 20 pence pieces. We've got 5 pence pieces. We've got 10 pence pieces, and we've got ones. And we've also got 2 pence pieces, haven't we? I think we need, there's 4 coins. 50 and 20 would make 70, and then 1, so we can't have 20. I think we've got to have a 50 in it. Yes, we have to have a 50. And then I think we'll have 2 10s and a 1. 50, 60, 71, yeah. Question 5. Complete each statement using one of these symbols. Less than, equals, greater than. 2.54, look at the 4, and here is a 0. That 4 is bigger than the 0. The first bit is the same, 2.5, 2.5. So it's bigger. So 2.54 is greater than 2.508. 0.25 is the same as a quarter. Now, if you didn't know that, you can use the calculator, and we just do this. And then we SD it here. And we get 0.25. So we can see they're the same. So we say equals. Now this calculator I'm using, it's one that's been used by Casio or made by Casio many years, and it's a very good calculator, and they've now brought out a new one. I'm not as happy with it because you have to do more steps to get the same result, but I'll show you how to do that with the new calculator, which is called the Casio FX 83 GTCW. Fraction key, 1/4. No equal sign, we have to press XE. That gives us the quarter. Now to change it to decimal, we've got to go format, then move it down to decimal, and then go XE again, 0.25. So more button presses, but we can get there. The last one, 2 and 5/2. Well, again, you can use the calculator. Let's have a look at the calculator and change it to a decimal. 5/2, 2.5. So 2 is less than 2.5. Less than. Question 6. Here are 3 solids: a cube, a square base pyramid, and a cone. How many faces does the cube have? Well, a cube has got 6, but we can count them up. If you imagine you've got it labeled around the top there like this, so imagine put a paper around the top, and then you've got the front here and going through to the back there. 1, 2, 3, 4, 5, 6. How many edges does the square base pyramid have? Well, edges are of course the lines here. We've got one there, we've got one there, one there, one there, and then we've got the 4 around the base here. So we've got 1, 2, 3, 4, 5, 6, 7, 8. And how many vertices does the cone have? Well, he's only got 1 stuck at the top there. Vertices being points. Yeah, where lines meet. Or this is a funny one, but anyway, I mean, cone's got 1. Here's a number machine. Input 12 minus 4 times 5 gets the output. This isn't using BidMath. You have to do each step. So 12 minus 4. 12 minus 4 gets us to 8. 8 times 5 gets us to 40. Here is a different number machine, 7, and then something gets done to it and gets divided by 2, and we end up with 9. Okay. This number here must be twice what 9 is, because if you divide 2 into it, you end up with 9, so it must be double the 9. So 7 plus something equals 18. So what do we have to add on to 7 to make 18? We have to make 11. So you put that in there. Oh, we've got to put plus to know what to do with it. Here is a different number machine. The input is X. And when I first looked at this, I thought this was the number X, but it's not. It's times. It's timesing a number. Minus something gives us Y. And they give us some examples. So let's put the first one under here. When X equals 5, Y equals 13. I'm going to actually guess some of these. If it was times 3, we'd end up with 5 times 3 would be 15. And then we could take off the minus of 2 would get us to 13. So I'm going to try that first, minus 2, and see what happens. And then try this one. And when X is 10, 10 times 3 is 30. 30, yes, 30 minus 2 again would be 28. So yeah, they're 3 and 2. I guessed them because if I went x times 2, I'd only get 10. I'd have to make this into a negative number. And I just thought that'd be too complicated. I think that's the best way of doing it. Work it out, just guess it, and reason it through. Otherwise, you're into something like simultaneous equations, which I'm sure they're not aiming at. 5 times 3 minus 2 equals 13. It's a bit over the top, but never mind. And then we got 10 times 3 minus 2 equals 28. So that's our 2 examples, 3, 2. Okay. Question 8. A pack of pegs costs 40p. Bar of soap costs £2.20. A basket costs £7. Dan buys 2 packs of pegs, 1 bar of soap, and one basket. What fraction of the total cost is the cost of the basket? Let's work out the total cost first. He's got 2 packs of pegs, they're 40 pence, so that's going to be times 2 is going to equal 80 pence. And change it, we'll do it all in pounds, so you need to have the same unit. So we're going to make it 0.8 pounds, like that. So we can go 0.8 plus the £2.20 plus the £7. And I like to put the zeros in. You can use the calculator if you want, don't need to. 8 and 2 is 10. 7, 8, 9, 10. So it's £10 altogether. I think we get 1 mark for that bit, 1 mark for this bit. And now we've got to do what fraction of the total cost is the cost of the basket. Fraction of the total cost. So the total cost is the thing, if you like, and the basket costs £7. So you do that simply by go 7 divided by the £10. That gives us our fraction, 7/10. Yeah. Calculate the root of 625 plus 7 cubed. Now we could just plug it all into the calculator and we will get the answer, which they may give 2 marks for, because we've got to get both bits right. But I think it's worth showing them in sections. So what we're going to do is we're going to square root 625, 25. Plus, and we'll do the 7 cubed separately. 7, yes. Do 7 cubed like this. Should do 7 cubed, which is there. And put our answer down here. So now let's add we'll add the 25. 368. Bit of overkill, but never mind. 8,400 fans go to a rugby match. There they are in there. 6,850 of the fans support the home team. So there's our home team here. Yes, home team, and that's the fans. The remaining fans support the away team. Okay. 20% of the home fans wear a scarf. That's going to go in here. 2,319 of all the fans wear a scarf. Well, it looks complicated, but let's do it steadily. Let's work this one out first. Well, if there were 8,400 fans went to the rugby match, there's the home ones, the away ones. So we take this one from this one, and we're going to end up with this. We'll use the calculator. The next bit, 20% of the home fans wear a scarf. It's going to go in here. That's 20% of this one, because that's the home fans. So we do 20% by find 1%. We do that by going 6850, divide it by the 100, gives us 1%, and we want 20%. Then we times that by 20, and we can do that in the calculator. Move that up there. 2,319 of all the fans wear a scarf. Of all the fans wear a scarf. The home fans wear scarves there, and the rest of them are in there. So what we can do is 2319 minus 1370, and we're going to put that in. 949. And now we can do the rest. Out of the 6850, that many 1370 wore the scarf. The rest must have not worn the scarf. So we do minus 1370. That's that one. 5480. And then this final one is 1550 minus the 949. 601. goes to there. Okay. Question 11. We've got this triangle on a grid, an XY grid. We've got a vertical line there, x equals 6. 11a, work out the coordinates of B. There's B there. Well, it's the x in y, so let's put the x in y down. The x is -2, and it's on that vertical there. Everything on that line there is -2. So where A is -2, B must be -2. And similarly, this one, C, the y value is at -1. So there we go, where everything on this line here is -1. The y value is -1. Okay. Point C is reflected in the line x equals 6 to point D. Work out the coordinates of point D. Okay, that's the point we've got to reflect. It's going in this line here. It's like looking in a mirror. If you looked in a mirror, this triangle would flip right over like this, and you would end up your 2 this way, and it's going to go 90 degrees to this, so it's going to go to that way. So we're at this point here. And where is that point? That point is still on this line here, which is -1 on the y part. And where is the x? Well, x is 4 there, 5, 6, 7, 8. 8 minus 1. Question 12. Liz records the distance of some runs and the time each run takes. Here's our distance in kilometers. 3, 4, 5.5, and so on. The time is in minutes, 14 minutes, 17 minutes, so it's in minutes, okay. Kilometers, minutes. There's the time in minutes. Running distances and time taken. Well, the distance there. Complete the graph by adding the missing label. Well, if this is time, this bottom one must be distance. So we're going to go distance. And see there, they put in brackets the minutes. We'll put in brackets the kilometers. Okay. And 12b, describe the correlation shown in the scatter graph. Type of correlation is positive. As the distance increases, the time increases. So it's going generally upwards like that. We would just call that positive. And I would say you could do a pretty good line through there. So I think that's going to be called strong. I mean, you can have a positive correlation which looks like sort of this. It's still positive, but it's a bit weaker. Question 13. AB is a straight line. There's A to B. Is y half of x? A question mark. There's x here. Tick a box. Well, we've got to work out x first. That's what I would do. Well, let's work out y. Y equals, now in a straight line, A to B is 180 degrees. All the way around is 180. So we can say 180 minus 127 equals, and you can use the calculator, no problem. 53. What's that bit? This bit here is around a circle, around a point, which is going to be 360. All the way around is 360. And it's made up of 163 plus 90 degrees. And then we get the x. Now, the way I'm going to do this, I'm going to say x equals 360 minus these two added together. I'm going to put them in a bracket. 163 plus 90. That's taking all that lot away. You could say 360 minus 163 and then minus 90, but I think it looks neater like this. Must use the bracket though. 107 times 2 of 53 is 106. Is y half of x? No, 53 is not half of 107. It's half of 106. No. So it's 3 marks. We definitely get 1 for this. We get 1 for this bit at the bottom. And tick in the right box. Again, if I'm explaining too much, then let me know. Or if you'd like to see more, let me know. Multiply out 3, open bracket, 2x plus 8. Okay. Well, that's going to be 3 times, the way I like to do this, I go 3 times 2 is 6. So my answer is 6x. And then 3 times the 8 plus 3 8s are 24. And that's it. Yeah. Question 15, complete these statements. You end up with 9x. You've got 5x here. The x's aren't going to change. We've got 5 of them there, 9 of them there. We need an extra 4. 4x. Oh, and then we've got to do this bit. Y times something makes y squared. Well, it must be y because a square of something is something times itself. We've got these things called t's, and we take away 2 of them. We must have started with 3 of them. Question 16. Tins of beans are sold in shop A and shop B. So let's have a look. Shop A is 1 tin is 64 pence. Buy 4 tins for the price of 3. Okay. Shop B, 1 tin is 62 pence. Pack of 3 tins, £1.70. 10% reduction in price on all packs. At which shop is it cheaper to buy 20 tins? Okay, state how much cheaper. 4 tins. 4 times 5 was 20. You can buy 4 tins for the price of 3 tins. Okay. So what's the price of 3 tins? It's 64. That's going to be 0. I'm going to do it in pounds. 64 times 3. SD it, which equals £1.92. It's £1.92 for 4 tins because we get them at the price of 3 tins, which we've just worked out. And we're going to buy those 4 tins 5 times. So that is the cost of that one. So that one is £9.60. I'll put the pound sign in. Pack of 3 tins, £1.70. Okay. Well, we buy as many packs of 3 tins as we can because we get a reduction. Because if we bought them separately, you're going to have 3 6s are 18. That's going to be 186. So you get a small reduction on that. Pack of tin is £1.70. We're going to buy as many of those as we can. So let's put that down, 1.7. Why? Because it's cheaper. And 3 goes into 20. We've got to get 20 tins at 6 times. So that's going to get us 3 6s are 18. That's going to buy us 18 tins. Put that there, 18 tins. Pack 3 cost. There. And that gives us £10.20. Okay. And then we get a 10% reduction in the price on all packs. And these are the packs we've bought. But we've only bought 18 tins, but we can get a 10% reduction on that. So that means we've got 2 ways of doing it. We can take 10% off, or we can times it by 90%. And that's what I'm going to do. I'm going to times it by 90 over 100 and put the price there. £9.18. Okay, so far so good. And then we got to add on the other 2 tins because we've only got 18 tins at the moment, but we can only buy those as separate tins, and they're going to be 62 pence each. And I can show them is nothing wrong with this. We can put it on like this. Again, overdoing it, but never mind. £10.42. Okay, that's that one. So at which shop is it cheaper? The first one. So we must answer the question. Shop A. I'll put a tick by it. I'll actually say cheaper. Cheaper, and then we've got to work out the difference. I'll put it down here. £10.42 minus the £9.60. 0 from 2 is 2. 6 from 4 won't go. Cross off the 10, make it a 9. 6 from 14 is 8. 0.82. And we'll show the units, which are pounds. Could have said 82 pence, but that'll do. There are 30 students in a class. 12 of the students have school lunch. Work out the ratio students having school lunch to students not having school lunch. Okay. This is the key thing. It's 30 students, so it's out of 30. So what you have to do is if 12 of the students have school lunch, okay. And so we have to find the ones that not having school lunch is 30 minus the 12, which is 18, isn't it? 18. So it's 12 to 18. All right. The total number of parts is going to be 30. That's how I like to look at it. Or total number of students in this case is 30. 12 of them eat lunch, school lunch, 18 don't. Now we've got to break it down. What goes into 12 and 18? We can just keep going down in 2. So we can have both of these, 6 to 9. Now I see, oh, 3 goes into that. 3's go into 6, 2 to 3. So that's our simplest form, 2 to 3. But we can put it in the calculator like this. 12 over 18, we should get 2/3. Yes. 17b. In a different class, students wearing glasses, 2 students not wearing glasses is 3 to 8. What fraction of students in this class wear glasses? Well, the idea is sometimes you can think, oh, it's 3 over 8. Well, no, we need to know how many students wear glasses, and this is a small class. The number of students are 3 who wear glasses, 8 who don't. So it's 8, 9, 10, 11. There's 11 students in the class. What fraction of students in the class wear glasses? It's 3 out of 11. So always find out the total. The ratio 4 to 9 is written in the form 1 to n. Work out the value of n. Well, that must be if 4 to 9 goes down to 1 to n. I'm just going to say divide both sides by 4. Divide by 4. So we can just go literally in the calculator, 9 over 4, and it'll give us, well, we can put it as a fraction, but it's 9 over 4, which is fine, but we can SD it, 2.25. So n is 2.25. Okay, or 9 over 4. Show 9 over 4 there so they can see it. There are the first 3 patterns in a sequence made up of small squares. There's our small squares. Okay, It goes 1 and then they expand it 2 along the bottom and then it goes 3 along the bottom. So we're going to go, and then they stick a square on the corners. So we've got to go 4, haven't we? Because we went 1, 2, 3, 4. Okay. 1, 2, 3, 4, up 4. Stick one on the corner, each corner. Oh, I'm looking at this, I can see what they're going to ask next. Because these are square, you know, that's 2 squared, that's 3 squared, this is 4 squared. 1, 4, 9, 16, and then we add 4 on. So it's a square, something to do with a square. 18b, the expression for the number of small squares in pattern n is n squared plus 4. Oh yeah, we saw that, didn't we? Work out the least value of n for which the number of small squares is greater than 500. N squared plus 4 is greater than 500. We can take the 4 to the other side. N squared, well, we minus 4 from both sides, basically. N squared, which 500, I'll put it down like this to start with, minus 4. Okay, so therefore, we can say it like that. Therefore, n, if we square root both sides, get to n, we must do the same to the other. And it's going to be 496 square root. Okay. So let's put that in. Square root 496. Right. So n has got to be greater than 22.27. Work out the least value of n. It's the number of squares. Well, we can't have 0.27 of a square, so, and it's got to be greater than, so it's going to be 23. Use Pythagoras' theorem to work out the value of x. Give your answer as decimal. Well, c squared equals a squared plus b squared, where the hypotenuse is c, and one of these is a and the other one's b. Okay, so we're going to put 8. This time we're going to make this into x squared, okay? So, because that's what they've labeled it. X squared equals whatever these are, 31 squared plus 24 squared. That's our Pythagoras' theorem. And we're going to work this bit out first. X squared equals. And then, just like we did in the other one, we've got to square root both sides to get to x. So x equals the square root of 1537. I've got quite an old video now of moving equations around. I may put a link in. It's called transposition of formula. So let's do that. We've got a square root, and you just go square root the answer. Give it as a decimal, 39, 4 places, 2046. Rounding that 5 up by 1. Okay, I think that'll do. Rick claims most of the flats in his 8-floor building are energy efficient. He samples 45 flats from floors 1 to 5. Give a reason why this sample may not be useful in testing Rick's claim. I think that should, I'm sure that's all they're asking. Why would you do 1 to 5? You'd go all the way up, wouldn't you? Question 21, 3 open brackets, x minus 1 close bracket is identical to 3x minus 3. Oh, they tell us it's an identity. We know that by 3 lines instead of 2 lines for equals. An identity really means it's exactly the same. It's just a different way of showing it. Right, it's true for all values of x. That's what they want. Has to be, because it has to be because it's the same thing. Question 22. K hires a digger. The cost per day is £24.50 for the first 5 days, reduced by 20% for day 6. The same as day 6 for day 7 onwards. So, okay, 6 and onwards is 20% less. The total cost is £259.70. For how many days did K hire the digger? You must show your working. The cost per day is £24.50 for the first 5 days. So each day is £24.50. So what we're going to do is work out 5 times that, £24.50, because we need to take this away from the total. Right. 5 times it. I'll use the calculator. So it was for 5 days. Cost. That was the total 5 days cost. Okay, well, now we're going to take this away from this one, because that'll tell us how much was spent on days 6 and 7 onwards. Okay, so on this bit we've got 137.20. For day 6 and day 7 onwards, it's £24.50 reduced by 20%. So there's 2 ways of doing it. We can find the 20% and take that away from £24.50, or we can say, oh, that means that day 6 and day 7 onwards are really 80% of the original cost, because that's 20 off the 100. Let's do it both ways. If I'm overdoing this, again, let me know. I'm just trying to put loads of ideas in so you can do it a number of ways. So let's do this one first. £24.50 over the 100 times by 20. That's how much we take off. £4.90 comes off of that. So £24.50 minus that. £19.60 is the daily cost from 6 days onwards. And we just divide this £19.60 into the £137.20 to find out how many days there are. Okay, but the point I was making about the 80% thing, you could have gone 2450, £2 divided by 100 times by 80 and got straight to this £19.60 rather than doing 2 steps, finding 20% and then taking it off. If you realise it's 80% that's left is the same as taking 20% off, you can get straight to it with less steps. Just show you quickly. £19.60. And of course, if you really get used to percentages, you can realise you can just times the whole thing by 0.8 rather than divide by 100, then times 80. But let's not overcomplicate it. So now we take the £137.20 divided by £19.60. And I know I repeat myself, but if you get used to doing fractions rather than the division sign here, you get very used to the fact that a fraction is a division. 7. So it was an extra 7 days on. So the ones at 20% reduction, there were 7 days of those. So it's 7 days plus the original 5, which we had up here. I'll put 7 days down there. And up here, I'm going to go 7 plus 5 in there. 7 and 5 is 12. The front elevation of a cuboid is shown on this centimeter grid. There's the front elevation. Volume of the cuboid is 42 centimeters cubed. As soon as I see 42, I think of 6 times 7. You've got 6 sevens equals 42. Got 6 squares here on the front. The way you work out a cuboid is its length times width times depth. There's our length, there's our width. Length times width is already given us the 6, 2 times 3. So if we draw it in 3D, you're going to end up with this cuboid here, like that. And it's going to be 7 long. Okay, because you've got 6 squares, the face, times the length. It's the same as a prism, basically, the area of the face times its length. So we've got to draw the side elevation, which is this one down here. It's going to be 2 high by 7 long. It's 7 by 2, so we just go 2 down there. 1, 2, 3, 4, 5, 6, 7. That's our side elevation. On Monday, Lars swims 50 meters in 40 seconds at a constant speed. On Tuesday, Lars swims 1.5 kilometers. Assume he swims at the same constant speed as on Monday. How many minutes does he swim for on Tuesday? Minutes is what we want. Okay, I'm going to find the number of seconds it takes him to swim a meter. 50 meters in 40 seconds. And that's distance over time, which is going to be speed. Okay, so 50 divided by 40. I'll use the calculator. That's 1.25 meters per second. Tuesday, 1.5 kilometers times by 1,000. We change it to meters. 1,500 meters. The reason being, I've got this in meters. Got to use the same units. Right. If it takes him, for every second, he can swim 1.25 meters, but he swims 1,500 meters. So I take the 1,500 meters and divide it by 1.25 meters per second. This is meters. I'm going to end up with the number of seconds. And if you're not sure about it, imagine if it took him 500, he could swim 500 meters in a second. Well, it's going to take him 3 seconds, isn't it? I know this is very fast, but so it tells you then, that's what I like to do. Do we know whether to multiply or divide? Well, if I divided 500 into 1,500, I'd end up with 3 seconds. So try to put simple numbers in if you're not quite sure which way to go. So we're going to go 1,500 divided by 1.25, 1,200. So it's 1,200 seconds. Now they want the answer in minutes. So let's put the answer in minutes. How do we change seconds to minutes? We divide by, so divide by 60. 6 is into 12. Well, 6 goes into 6 once, 6 goes into 12 twice. Oops, 20 minutes. But you can use the calculator, of course. In fact, on Tuesday, Larry swims at a slower constant speed than on Monday. In fact, so he's going slower. What does this mean about the number of minutes he swims for on Tuesday? Well, think of a race. The race is somebody who gets there quicker, isn't it? So rather than 20 minutes, he's not going to be do it in 20 minutes. He's going to take longer. So you'll be a bit careful. It's greater than the answer in part A to part A. Question 25. 4 people are taking part in a television talent show. Here are Amy's marks for the 6 judges. Okay, she get marks. 8, 9, 9, 6, 9, and 10. Not a 7 amongst them. Pie chart represents the phone vote. So this is the phone. Okay. And this is Amy. She's getting 162% of the marks. Amy's total score is found by 4 times the mean of her marks plus her percentage of the phone vote. So we got to find percentage here. Okay. 4 times the mean of her marks. How do we work out the mean of her marks? We add them together, divide by how many there are. How do we find out the percentage of her phone vote? Well, this is out of 360. So it's going to be 160 over 360. Because 360 is representing the whole. And then we times that by 100. Okay. So let's have a look. Is there anything else they want? Oh, work out her total score. Well, we'll do that here then. So Amy's total score. Right, let's do the mean first. It's going to be, we do it up here, 8 plus 9 plus 9 plus 6 plus 9 plus 10. Divide by how many judges there are. 1, 2, 3, 4, 5, 6. 6, that's the mean. I'll put mean there. So we can use the calculator. Put them all on the top of the fraction line. 8 plus percentage is going to be 162. That's Amy's thingy. And then divide by 360 times by 100. Okay. $45. Work out Amy's total score. Well, it was 4 times the 8.5, which was the mean. That equals, well, 2 8s are 16, and so 8.5 17. And so 4 of them is going to be 34. But of course, we can use the calculator. And then we add on the 45% that we just found. 5 and 4 is 9. 4 and 3 is 7. I expect we've got to put it down somewhere. So the answer is 79. That's her score total. House prices on a street increase by 5.1% each year. Show that after 14 years, the house prices on the street will be at least double. Well, this is compound interest, basically. It's compounding anyway. And there's a formula for it. So unfortunately, it's just one that you need to know. You could work out the price each year and keep adding it on. But the way this one works is you have to go, imagine the original price is a unit, just one like that. And then you need to capital, or if you like, the original price plus the percentage. Normally they show it like this, 5.1 over 100. Close the bracket up by 14. Normally they'd have a big amount there, but all you're doing is one. You don't even need the one there because obviously it's going to assume the one. So, which you could just say is the cost of the house. So what we're going to do is go open a bracket, 1 plus, use the fraction key, 5.1 over the 100. I get this right, we've got to go up to the side there, then close the bracket, then raise it to the power. You want this one, the x with the square on it, to 14. And that should come out at just over 2, I would have thought. Yes. 2.006. Doubled. Yeah. Town A has a population of 84,000, an area of 7 square miles. Town B has a population density of 4,695 people for every square kilometre. All right, they've got to change these over. So that one's miles, this one's kilometres. Population density is the population divided by the area. Which town has the greater population density? Well, this one's in square kilometres. This is square. We need to make this into square kilometres as well, because we've got to use the same units. 1 square mile equals 2.6 square kilometres. So they're telling us there's more square kilometres than square miles, in the sense that 1 square mile makes up 2.6 square kilometres. So it's going to get bigger. So we know that's going to be, I'm going to go equals 7 times 2.6 and do that first, which equals 18.2 square. We now know the area is 18.2, not 7, because we're using square kilometres. So we can say 8,400 divided by 18.2. So we've had to do a conversion. Again, over 18.2. 4615, whereas this one was 4695. Right, town B has a population density of 4695. This one's only got 4615. Which town has the greater population? It's town B. Okay, so I'm going to go, and if you want to, put little lines in like that. End of questions. Okay, I've also done paper 1 and paper 2, which I'll put on the screen now. Thanks for watching. Bye.